Hello and welcome back to another video. In this problem, we're given the function f and its graph, and we're asked some questions about it. So first, we're asked to estimate the value of f of 2. So we go to the value x is equal to 2, and we can see that the function passes through x equals 2 right about there. And if we look at the y value of this point, we can see it's in between 2 and 3. So let's just say f of 2, maybe a little bit closer to 3, is equal to 2.7. Again, it's just an estimate, it doesn't have to be exact. In part B, we're asked to estimate the values such that f of x is equal to 3. So now we're looking at y values, and we go up 1, 2, 3 to this line right here, which represents y equals 3. And we can see that we have these 2 points right here, and then we find their corresponding x values, which is a little bit more than 2. So let's call it 2.2. And about halfway between 1, 2, 3, 4, 5, and 6. So we can just call it 5.5. For these two x values, f of x is equal to 3. Next, the domain of f. The domain is all possible x values that the function can take. So we start at the left at -6. And we can see that it is continuous all the way through here up to +6. So the domain is -6, 6 inclusive, meaning we do the square brackets. The range of f is similar, except it's all the possible y values. So we go to the lowest possible y value we can see, just the furthest down on the graph, right here, at this value, which is y equals -5. And again, it's inclusive. And that goes all the way up to here at its highest point, which is +5. We're asked on what interval is f increasing. We can look for the period of this graph where, as we move left to right, as x increases, we also want y to increase. We can see that we start here. As we go, the function is decreasing, decreasing, decreasing until this point at -4. And it goes increasing, increasing, increasing up to this point right here at x equals +4. And it's important to note that this is not inclusive of these endpoints, so we do the parentheses, because you can't be increasing at a specific point. Is f 1-to-1? Explain. To prove this, we have to do the horizontal line test, which states that any horizontal line placed through the function can only intersect the function at most once. And if we take y is equal to -3 and pass it through the function right there, we can see it has multiple intersection points, meaning for these points, whatever their x values are, those x values do not have a unique y value. They don't have a unique y value because they have the same one. Therefore, we can say that it is no. It is not 1-to-1 by the horizontal line test. G, we're asked is f even, odd, or neither? How do we see whether this is true or not? Well, we can see that it's not symmetric about the y-axis, right? If we look here on this side, we don't see the exact same thing mirrored. So we can say that it's not even. Seeing that it's not odd is a little bit more difficult. If you can see that, yes, what's happening in the first quadrant is mirrored by the third quadrant, except it's upside down, you can maybe recognize that after seeing odd functions for a while, that this is in fact odd. But the easiest way to do it is to use the definition of an odd function, which is that f of -x is equal to -f of x. So for all these values right here, as we go into the negative x values, all of these values will also appear on the function just in their negative values. And that is where we see, okay, the function increases, increases, increases in value for a while, relatively linearly. And we can see it decreases in value relatively linear as well. Therefore, all of these positive x values are reflected by these negative x values. Then we hit a maximum point where the magnitude of the points is the greatest, and then we go back down again. We have the same thing here, just positive and negative. So that's sort of the visual way that you have to see is this function odd or even? Because you're never going to be actually able to plot enough points, especially if you don't have the equation of the function, to be able to test this. So in conclusion, f of 2 is 2.7. F of x equals 3 at x is equal to 2.2 and 5.5. The domain of f is -6 to 6 inclusive. The range is -5 to 5 inclusive. F is increasing from -4 to 4 not inclusive. F is not 1 to 1, and f is odd.